This time on the laboratory, you saw the dollar bill acceptor. Here's the nickel, dime, and quarter change acceptor and collection unit from that same vending machine. I wasn't sure what I was going to do with it, but I figured, hey, let's take it apart and see if I can scavenge anything out of it, because it's older than dirt. So, I'm looking to see if there's a date on it. Coin Acceptors Inc. It's got all the patents, made in the USA. So when it sits in the machine, the coins drop in here and then are deposited. And then when you want to release them, it's got these buttons that open the bottom doors. So, of course, it's got this other end of the plug from the bill acceptor, because they plug in together. And then that goes to the basic control panel. So, one thing if you notice or care, there's really no screws except for those right there. Everything is just held in with plastic clips, which is kind of interesting. So, let's see what's inside. There's no change in here. I already checked that. Now, the person I got the machine from emptied all of its money before I got the machine. So, there we go. That's one. And that one. So on the inside, we got some dip switches and a ribbon cable. Got that unplugged, and then it just comes right out. And again, very well put together, since there's literally no screws. Even the coin return part is a pin with a clip. So I'm actually really surprised at how this is engineered. But let's see about taking the rest of this apart. There we go. There's the brains of the operation and the little solenoids that deposit your change when you hit your coin return. And it is held on with another ribbon cable. This ribbon cable is soldered to the board. So that means I need to take out this top piece to get to the other end, which it looks like it's just held in with some clips too. You know, I actually have a spudger kit that might work. Should probably use it. It may not work. Just flexing. So I need something with a little bit more strength. So I use a screwdriver. There we go. So it's just held in with four finger clips there. Excuse me. And there is the basic circuitry. And now we can unplug this, which also has circuitry. And even this circuit board is held on with just some finger clips. So instead of screws, which is so common, this is using a technology that I haven't seen in a long time, where everything just popped into place. So I'm pretty surprised. But taking it out, we got these weird looking symbol notch thingies, whatever you want to call them, castings, sorry. And we have optical readers. A whole stack of them. And what's different than normal is it's using red light to read. I thought that's kind of weird, because usually they're infrared, not the color red. And then we have the buttons here. They protrude on this side, and when this is in, like so, that way, these buttons press on these switches. This one's really crisp. So this is an old style switch as well. It's a piece of flexed metal or springed metal, and it's lifted above the contact on the inside, right down in there. I'm prying it up a little. So what it does is, here's your solder pads, and there's your outer and inner of the switch on the top, then your connection in the middle. So when you press it, it connects this one and this one together. It's an old technology that works, but they've gotten away from it. Most buttons now are piezo style, or they use squiggly copper lines that interlace, and when you press, they squeeze together. But this is a technology you can replicate it yourself if you're making a project that needs a mechanical switch. So here is the plugs for this big harness, which also looks like it might just slide in. I'm actually kind of impressed with the engineering on this coin machine, or the coin acceptor, that it's all like snapped together. It's kind of strange. It's just not something you see. Everything is glued, screwed, and riveted into place. It's a tight fit. You can see the strain relief is cast into the shape of here, and then the wires are fed through. You can see there is slack if I stretch it, but you can't pull them out because this end is sealed even tighter. Most likely they fed it through and then got this side hot, so it shrink back. But it helps keep the wires from being yanked out. And then lastly, we have a transformer and a big old circuit board, which again is just held in by tension, just like everything on this unit. And now I know why there's screws on the back. The screws on the back are for the solenoids that dispense the change, because these are heavy pieces of metal and it needs to be supported, so they're screwed in. And then there's a couple of screws I saw here which hold the bottom plate in, which also supports the transformer. The transformer, there's no screws, but there's some notches in the plastic, and it's resting in the plastic like a foot. It grabs it. So kind of a interesting little setup. Bigger screwdriver. So let's take the solenoids out. That's one. Two. And three. Unplug the transformer and unplug the other side of the transformer. So, actually, just unplug all the solenoids as well. So, they did a very clean job on this as far as the layout. If you're OCD, you might get annoyed with like an offset, but this is a very clean circuit board. It's immaculately done. And this coin acceptor probably didn't work very well. And the reason I say that is these two resistors right here got really hot, and there's the burn mark, which is why before I dismantled the machine, it didn't work. The compressor worked, but the change acceptor and the bill acceptor wouldn't function. They wouldn't pull a bill in, and the coins would just fall all the way through right back down to the coin return. So, but the compressor worked, but it only got that down to about 50 degrees, which is not cold enough for a soda machine. So the failure point is right in here. Something is shorted out to where it's getting these resistors hot, or it's overdrawing. Could be the relay, because the relay is shared with the resistors. It could be something else downstream, but this is a very beautiful circuit board layout, which again is not something you see too much these days. They don't give you all the spacing and the straight lines and make it very linear. So if you're into electronics or your OCD, this is a very nice piece. And I actually know people that take circuit boards like this and frame them and fill them with resin, and they sell them on Etsy. It's weird. So people do buy them. This one's probably gonna end up in the garbage. I will probably just take the LED. I'll probably take this bank here, big capacitor. I might take the voltage regulator, and if this relay works, this little guy, I'll take that. And I might take the big relays too if I can desolder them. I'll check the diodes and see if they're any good. This set of diodes right here and the pattern I laid out is most likely a bridge rectifier to make it DC. So, like I said, this is a kind of a clean circuit board. Sorry for the background noise with a dog. I'm sure you can hear her barking. Doorbell was rung, and she's letting everybody know that somebody's invading her personal space. So, but anyhow, let's take out these bottom screws real quick so we can get out the transformer. Very vocal. And we'll see the transformer. If the transformer is any good, transformers I do keep. They come in good for other projects. If you're building something that runs on lights, or you have a transformer that fried, instead of trying to locate one, if you have a couple spares, you might actually have one in your possession. Oh, hey, I got a dime. So it wasn't all for naught. Let's see if I get this assembly to pop out. Those fingers are separated. That's separated. There we go. There we go. It's just a really tight fit. These three fingers fit in these three grooves, and then it just slides in and is held in with the screws. And so I'm talking about. The transformer doesn't fall out, but it slides out. So again, this was designed specifically, and it was done very well. I do give credit to companies that take the extra effort to make their stuff functional and clean. And all you need is a screwdriver to open it up if you need to get inside of it and get your lost dime. So, transformer is 117 volts AC and 12 volts DC out at 0.3 amps. So it's actually really, really low powered. This one wouldn't work for most anything because 0.3 amps is a couple of LEDs. This probably is just set up to run the circuitry, because most computer chips run at low voltage between 4, 5, 12 volts. They're not usually a high voltage. 9 volts is the most common that I found for chips. So this is probably just designed to power the power side of the chips, so the chips can do their counting and change dispensing. So this transformer is as nice as it would be to have at 0.3 amps or 300 milliamps. It's not a lot of power. It's a big transformer to power a very small amount of stuff. So I would recycle this. And then the solenoids, these guys, how they work is these fit inside here. If the pin will line up that way. So when it's on, or when it's resting in these grooves, which is your change dispenser. So you can see the hole. Holes are partially blocked, and then if I have it pull, it pushes the change forward, so it pops out just like that dime did. It was caught under the door. So that's, and it shoots it out right here, here, and here. So, tink. And that's how it dispenses the change. How this works is this little notch fits in that groove, and when you do it, it pulls in. And then when the power is released, it lets go, and that's why there's a spring. That's why if you are not doing anything, you literally shoot it out. And if you made this where it turned around, you could use it as a projectile. And I have seen, and when I was in electronics, we've done that with these type of solenoids. It's an electromagnet, and it pulls it in. And you can use this for other things. Give you an example of what I'm building with that this Pepsi machine is it has one of these that has a 15 millimeter solid stainless steel pin that when you press the button, it pulls in because it's designed to, and then after 6 seconds, the pin comes out, but it's got a stopper so it doesn't come flying out because it's a electronic deadbolt is basically what it is. So these can be repurposed. You can use them as a science experiment and take the ring off, rotate them around, and have them pull it and then let go and poof, shoots out. You can use them for other projects. So these are, and if you don't, you can recycle them. That's if you have a coin acceptor that you're getting rid of. And it's 117 volts DC. Whew, that's a lot of power. So I'm wondering if this is 117 volts DC, because it just says 117 volts, and that actually says the same. So I'm thinking this is what powers the electromagnetic coils. So this works together, which if that's the case, I'll probably keep the transformer. And that might make sense. If this is plugged into a wall socket and this is a rectifier, which converts AC into DC, it would rectify your 110 to 120 volts AC that you get from your wall socket into a 110 to 120 volt DC. Most electronics work at a 10% margin, so 117 volts means it can go as high as 128.7 technically, and as low as 106, 105.3 technically. So it's just really high powered. So to use this, you would need to have a 117 volt DC converter. And if you salvage this part of the board, you might be able to make one. You can also buy a DC generator that goes that high if you wanted to and do it. You can wire a handful of car batteries in series and do it. Be careful if you do anything like that. It's extremely dangerous when you're working with power of that high, especially DC. AC will throw you away from its point. DC will hold you in. So, but it's got some salvageable components. It's pretty basic design. Like I said, it doesn't give me the year. It just has all the patents. I can look up the patents and get an idea. But it says it's a 117 volt unit, so this whole unit is DC. And yeah, there's no other markings. So kind of strange. This is pretty self-explanatory. It's just a set of tubes that the coins fall in, and then this is the bypass for your coin return if you put in a slug or something. Nobody does that, right? So, and let's see what it takes to open this guy up. Again, no screws. And just examining it, I see a couple of fingers here that push in, so we're going to try that. Stuff out of the way. That's one. That's two. There we go. So this also has some magnetic solenoids, much smaller, and they don't have the protective sheathing over it. And we got some inductors, old school. Ah, this circuit board uses screws. Look at that, they changed it up. What are we caught on? This ribbon cable, will it pop off? No. So this ribbon cable is holding the circuit board in, and it's inside here. Let's see, how does this thing open? There we go. It's just got a couple of fingers. And there's the other circuit board, again, held in with 2 screws. And we got some more inductors. I'm wondering if these detect metal slugs, because a metal slug will have a different magnetic signature than a coin. Our coins aren't magnetic because they're nickel, and zinc, which aren't magnetic, and copper, and a few other non-ferrous metals. Now, you probably won't have much of a use for this, but these little thin wires actually come in handy for projects. If you have one of those solar rockers, you know, you get them at the dollar store or Michael's or $1 or $2, and you put them in the sun and they swing back and forth. I see them all over the place. They're really popular out here, mainly because we live in a state that the sun never goes away, it seems like. So, but inside those solar rockers, they have these underneath. And if they fail, because you can see how small those wires are, they're just itty bitty, you can rewrap it, because these are coated in a varnish. You can also use this for other stuff. So I have coated wire, just thicker than that. So I'll probably use or keep these for that, just to have extra wire. And so I can actually get this out, I am going to end up cutting this ribbon cable because it's soldered on both sides. Go. And yeah, there's another set. So these on this side, those on the other, because these are right on the other side of this, on this plate. This is not metal, this is rubber. It's kind of a foam rubber. You can see how I can move it. So it's all non-magnetic, which is why I think this is most likely to detect metal slugs. So I remember in the old days, we used to go to electrical panels and find the slugs that were the same size and then use them as quarters. But, you know, nobody does that. That's bad. But vending machines got smarter, and apparently this is how they got smarter. They used this is also on the same rubber stuff, foam rubber. And that's probably how they did it, and it's just literally just glued onto that foam pad. Cut the wires off and then good to go. So they just had a little dab of glue in the corner and one right there that held this foam pad to the back of those. We got a couple of LEDs, transistors, inductors, a whole bunch of chips. And again, I know this one had screws, but look at that layout. It's straight, clean, very nice. They're not all angled and stuff. If you need ribbon cable or some short pieces, I just throw it away. Or actually, I send it to a wire recycler, because I am not a big fan of reusing ribbon cable. Plus, I have a roll of it, so I don't really need any more. I don't use it on cars. I use it mostly on my day job. So... and it's a pain to work with when you have to recrimp it inside this. So cut that off. This compresses, and it's got little fingers that cut into each one of these wires, because each one of these ribs is a wire if you've never seen a ribbon cable. The red wire is the hot wire, which is about the only thing that's nice about when they do ribbon cables like this, is they always mark which one is the hot wire. So, but on here we have one removable chip right there. It's on a stand, so that means it's probably temperature sensitive for the solder. mean, you can look up the chips if you have something and you want to see if the chips are reusable for projects, like if you do Arduinos. You can desolder these or use a solder rework station and heat them up with air and pull them out. I have done it, but most of these chips are proprietary chips for counting and stuff, and it's not anything I'm going to use them for. So, and then on these guys, there it is. It's the same thing. So it's got a much smaller spring, and it's a much weaker, barely flies out. Same thing, it's an electromagnet that when you engage power, it pulls it in, and when you let go of power, it pushes it out. And there's two of them. And based on the size of the wire, they're probably a much lower voltage. I don't know if it says the voltage on here. Sometimes they do print it, sometimes they don't. Nope, just some barcodes. Yeah, no voltages listed. They're probably low voltage. I can always hook them up to a DC power supply. I have a DC power supply that goes up to 55 volts. It should engage these, and technically it'll still engage these at half voltage. It just won't be a very strong engagement. It's not going to slam in or slam out. But even if I end up not using the coils of wire for projects, I still do recycle them. A lot of the stuff I take apart, whatever I can't use, if it's recyclable, I will recycle it. It's optional, you don't have to do that. I do it for two reasons. One, helps the environment, and, well, three reasons. Two, it's supposed to keep costs down when they remelt the wire to make new wire, but the other reason is you get paid for it. So you get money for getting rid of stuff that to you is just garbage. Also on this, if you need one, you got a spring clip and you got a spring coil that you can use for projects. This is similar to what Lemax uses on their doors when they have houses with doors. They use a spiral spring with a finger on one side and a finger on the other, and that's what gives it the tension. They're much smaller and they don't have as many coils. The more the coils, the stronger the spring. The stronger the spring, the faster it closes. If you put this on like a Lemax house as an example, you'd break the doors off. So just to give you an idea how it works in case you've never examined yours, if you have a house, animated or not, that uses a spring. Because they also use these springs for tensioning where it just holds something in place versus using it for motion. So we'll pop off the C-clip. Can never have too many of those. If you work on projects or cars that have the C-clips, there's another name for them. There's a couple of other names for them. That's because they have a tendency to remove themselves from your sight line permanently. Here's another coil spring, which is what gave tension on this. And how this one worked is it fit right inside of this groove. You can see the mark, the line, right in there. So it sat in here, and then this one, which will be really hard to swing it over, sat right there. Holy smokes, I was able to get it. That's just a loaded time bomb right there. So springs, when they're under tension, are actually dangerous. There we go. So we'll release the tension off of it, make the spring safe. So anybody that's worked on struts understands what I just said. But, and then this, it looks like this whole front assembly technically just separates based on the notches, and you actually see it moving. It's just really tight. But there's no other electronics in here. There's really nothing scavengeable. I mean, I could unscrew the stud, since the stud is threaded into a nut. And you'd be surprised what you can use stuff like this for if you're one of those people that scavenges parts for projects like I do. So the plastic pieces I pretty much don't have any use for. You know, this, the casing. That'll probably end up in the garbage because they won't recycle this type of plastic. But the circuit board, I'll scavenge the 3 circuit boards, and I'll keep the solenoids, the transformer. I'm going to recycle it. I'll keep the wire coils. So, and everybody has a jar with screws, nuts, and bolts, and that's probably where this will end up. But I have a special bin for springs of all varying sizes. Small springs I keep here on the inside workbench, and then my large springs are kept outside in the storage cabinet, because small springs are generally not used in cars or outdoor projects, but stuff like this can be used in indoor projects. So, but that is the disassembly of a coin acceptor from a Pepsi vending machine. So maybe you saw how it worked, get an idea, you know, like it, don't like it. It's just something different. I don't see too many people dismantle money holders. So, but anyhow, that concludes this video. Till the next one, thanks for watching. Real quick addendum, I was wrong on how this worked. I was looking at it, and so I'll use that dime. So when you deposit your money, it goes through and then determines what size hole. That's what one of the scanners on that circuit board does. And then when you want your money back, this drops it down, and then it either drops it out the bottom into the tube, or it bypasses it into the coin return. So this doesn't eject your money out of the front. The money sits and rests on top of this, and then every time this moves, it acts as a slide. So it sets on top, determines what you're going to do. Then once it's all accepted, it pushes it down to the next step, and then when it's done, drops it into those tubes that hold the change. So I was incorrect in my assumption of what it did, but staring at it, I realized I was wrong, and I figured I'd show you that I had to correct it, and that it's a goes in the top and drops out the bottom. So, but anyway, again, thanks for watching. Till the next one.